We'll get started with our second talk. So for the second talk for the day is performance testing using K6. We have two people with us. One is Monica Sharma and the second is Ankur. Over to you guys. Just start with this session and just give a just an intro about you guys.
Yeah. Thank you. Can you see my screen?
Yep, I can see. Folks, can you see the screen? Just ping an S. Yeah, Ankur, we are getting a couple of yes. Yeah, good to start.
Perfect. Okay. So we're here to talk about performance testing with K6. I'm Ankur Jain, and
hello everyone, I'm Monica.
So the question we want to address is why performance testing? So the purpose of performance testing is not to find any functional bugs or defects. It's more of to eliminate the performance bottleneck in the application. And it's more focused on application performance, stability, scalability. So whenever you try and build an application and before actually putting it on a platform or even put users to test, use it in a live environment, you want to understand how that application is performing and what behaviors does it has, right? To identify if there are bugs when there are multiple users using it, or there are different stability issues that happen, that you don't have enough resources of CPU or memory or enough amount of connections. There can also be stability issues because of that. And then the scalability issues, like for example, you want to scale up from one number of set of users to the later number of users, let's say 100 to 500, you might face some issues. So that's where you actually use performance testing, right? The different types, as I said, at different stages you can use different types. So there's smoke testing, there's load testing, there's stress testing, there's smoke or endurance testing, soak or endurance testing, and then within the stress there's also spike testing. Let's talk about what these individual testings are about, which I said. So smoke is to understand what's the minimal load your application needs takes, right? So when you start testing a performance testing an application, you want to understand what's the minimum load your application can get a number about it. So it's more of building a script which has no errors, and then you run your performance test, give a lot of users and build a scenario around it, and try and identify a minimum load where you don't get any errors to, right? So that's smoke testing. Load testing is more of about understanding how your application would behave on a normal and a peak load with concurrent or use requests per seconds. So this is a very specific terminology when we do performance testing, that there are concurrent users which you simulate your behavior with, right? Or there is a request per second limit which you've identified in your previous test, and you want to know how the application would start behaving in such circumstances. So you build up a test around it, typically on the load you're expecting, and then the maximum load where you could reach. And it's about like a standard and a continuous performance of your infrastructure which you can figure out. Stress test, as it appears, you're going to stress the application. You're putting a lot of load to check the reliability and the stability of the application. So it's more of about testing your application or your web service in extreme conditions. So it's to test out the behavior in the extreme conditions, about the maximum capacity your application can take in, figuring out any breaking points or the failure points of your application, at what point your application might start breaking or at all, and then once it breaks, how quickly can it recover? Can it recover automatically, or does it require some manual intervention? Let's more talk about spiking. So spiking, as the name suggests, it's a surge of traffic, like a lot of traffic coming to your application altogether, and how your application starts behaving to it, and then how it's going to respond when you try to recover that from the traffic. Soak testing would be more about, again, reliability and stability. Earlier, we were talking about the application. Now we're going to talk more about the infrastructure side of things, about any memory leaks that happen or any CPU consumption that are over spiking, or you have insufficient storage of data or logs that happens, or there's a misconfiguration or an incorrect configuration for your application. To understand all this, you need to soak test, right? So that's one strategy, or if you want to identify any infrastructure failures. And that's how you fine tune when you do soak testing.
Ankur, sorry to interrupt in the middle. I guess I am getting the message that the PPT is not being fully viewable. I don't know if it's a single issue or something. Guys, can everyone ping that if you can able to see the PPT in the full view? Just ping an S if you can able to see. Awesome. Sorry, Ankur, it was just one guy's issue, I guess. Sorry, continue.
It's okay. Okay, so let's drive towards the difference between the functional and performance thing. So I ran through a few, testing strategies, but you could say that they could be used both in functional and performance at the point of time. But how are they actually different? So to figure out the actual difference between the two, so in the functional testing, or the functional aspect of testing, you test with definite amount of inputs and there are expected outputs out of it, right? But in performance, you're testing the behavior of the system, how the application would respond with a certain amount of load or in a condition you're putting it into. It can be done, functional test can be manually done also, checking few certain scenarios, or you can have a regression suite which is automated. But you would prefer having like a performance simulation that is automated, because you want like a bunch of users from 500 scaling up to 10,000 or thousands of users, that you want to simulate a behavior and get the output of the application. So one user is mostly performing the test when it's a functional test, right? It's an individual user on their individual device they're doing the test, whereas you're using several users which are virtual users, but then there are several simultaneous requests that are going on in performance test. Functional and performance both have a customer, tester, and a developer. That's the basic UAT which you do. But then in performance, you also would like to involve someone who has more information about your database, your network management, and also your infrastructure management, because these are things you want to monitor. It's your background changes that are happening. The memory is maybe changing, getting used more. The network connections are changing because you're acquiring more users, right? And in functional tests, it's not necessary that you do it in a production similar environment, or at least the environment that you're using is closer to the production. But in performance, we suggest, and it's recommended that you use a hardware and the infrastructure that's very close to the production, because that's how you get an actual simulation of your production behavior, right? Let's come back to the point where we started, that we want to talk about cases. So I'll hand it over to Monica.
Yeah, thanks, Ankur. So the very first question we have is, what is K6? So K6 is a performance testing tool. To achieve the maximum performance, tool itself is written in Go, embedding a JavaScript runtime, allowing for easy test scripting. So the key feature of it includes CLI tool with developer-friendly API. Other one is scripting in JavaScript. So basic knowledge of JavaScript is required, or we can call it as a prerequisite in order to write test in K6. And then we have checks and threshold. So this checks and threshold, we are going to discuss this in the coming slide. And apart from this, K6 also support TypeScript. So we can also write the K6 test in the TypeScript. So next is what K6 supports. So K6 supports these protocols and request methods. So the request methods like put, post, delete, patch, get options, these are supported. And apart from these, the request methods which are available, for example, head or something like trace. So these can also be used with the help of, these can also be added as a test with the help of with the help of request. Apart apart from these support protocols and request method, K6 also supports GraphQL APIs. Next is, before jumping to the next section, let's first know what is virtual user. So virtual user is an entity that executes a test and make request. And it also simulates an actual user session. They run scenarios and keep repeating in the task until the task is over. So this is the basic idea about what is virtual user. But in the coming slides, we'll get to know how to use virtual user and what relevance does it hold in the test. So the next we have K6 Cloud. So K6 also provides web UI in order to run performance tests and get the results on the go. So here we have a sample API call. So this is called as test builder. So in the web UI of K6, so we have a test. We have an API called login auth token, which has a request method as post, and the URL or the endpoint ending with auth token login, and it accepts a request body as JSON with username and password, with the username and password. And after mentioning all these details about API, we have to mention the load configurations, which accepts the number of virtual users, for how many virtual users we have to run the test, till what duration, and which kind of strategy we want to opt for. So as Ankur has described, like there are different strategies or different types of performance testing. So here we have to see that which kind of performance testing strategy we want to go for. For example, whether to go for load, soak, spike, or stress. So that also we can make a choice from here. And these are the test results which we will be getting after the completion of the test run. So in this, as we can see that this is a basic graph like structure will be getting. And then in the below, in the HTTP section, we'll be seeing which all API calls have been triggered or tested, uh, and we have ran it according to our strategy. Apart from that, in case if we have put any checks or threshold, it will be displayed as per what we have mentioned in the test builder. And apart from that, we can compare the results also. Like in case if we have the previous run, then we can compare the result with the same. So this all we can see in the demo. So the next thing is K6 recorder. So K6 also supports the recorder functionality. So which is like, instead of writing the test manually, K6 provides the test recorder extension on the Chrome to simulate, load, and generate a baseline test. So for this, we just need to add the extension which is called as K6 browser recorder in the Chrome, and we can use that. So we have recorded a very small video on the same. Okay, so I'll play from the beginning. So here in the Chrome extension, I have started the recording. And after starting the recording, we have to go through the same flow which we wanted to record. For example, in this, I only want to record this particular API. So for that, I'm re-triggering the API by refreshing my screen. by refreshing this web page, which also triggers this particular API call. And after doing that, I'll stop the recording. So once you are done with your process or with your flow recording, you have to stop the recording, and then it will navigate you to the K6 page, where it will ask you to save the script with the required name, and it will give you two options, whether to go with the test builder or whether to go with the script editor. So the test builder is something which we have shown in the previous slide, which provides the web UI kind of thing. And let's say when we select the script editor, so here it will create the script which is in K6 format. So it will just automatically create the script for K6 so that we can just add this code snippet to our K6 script. Okay. So the next we have K6 CLI. So K6 CLI is complete open source. The very first thing is that what all installation does it require? So the very basic thing is, like, first we will be using an IDE. We can use either Visual Studio, VS Code, or the IntelliJ. So there is an installation process in order to install K6. So for Mac we can install it by using brew install K6, and for Windows there is an installer for that. Likewise, the process of installation in Linux and CentOS is also documented in the website, in the K6 website. So now the question is that we got to know about the basics of performance testing, what kind of strategies are there. Now we get to know about what is K6. Now the actual question is that what are the steps we have to take in order to write the test. So first step is create the test script for respective protocol and the request call. So these are the very high level steps which we have to take in order to start writing the test script and till the end where we are visualizing the test. Okay. So the second step is select the type of performance strategy, whether to go with load, soak, stress, or spike. Step 3 is build scenarios using different executors. For example, there are different executors like shared iteration, constant virtual users, ramping virtual users. So we don't have to worry about these different executors for now. We are going to cover this in the coming slides. Okay. So step 4 is executing the test, and after executing the test we have to we'll need to visualize the test. So by default, and with respect to visualization, visualizing the test or the result, so K6 by default gives the end of test summary report, but we can get the report in CSV or Grafana with InfluxDB, or JSON report can also be fetched. So the next we have is that what are the different ways of writing script. So in case if we want to run our script in K6, are there any ways of writing? There are different ways of writing it. So first one is to write your own script without any converters. So when you know everything, like what you want to write, or which API call to test or to write the test for, so we can just simply write our own script. That is called as without any converters. But K6 also support there are K6 also support different kind of converters. For example, let's say if you have a API call or API collections in the Postman, okay, and you want to write the test for all of them or some of them, so you can export that collection and use Postman to K6 generator and convert those API calls to the K6 script. So there are different generators which are provided by K6. For example, Postman to K6 generator, Open API generator, HAR. So if in case if you have recorded the API call in HAR format or Fiddler or through Fiddler, so you can use HAR to K6 generator or Fiddler to K6 generator. This is the basic request. This is the basic request call which we have considered for the demo, where it accepts the post as a request method, the URL as which ends with the endpoint auth token and login, and also accepts the request body as JSON, and it accepts username and password. And in the response, it gives refresh and access token. So the next we have test script creation. So first we have to write the script, right? So for that, we need to import HTTP from K6 library, which is the line number 1. After that, we have to create a default function. In that, we have to specify that which URL or endpoint we want to test, what is the payload for that, and then in case if we have specific header, we have to mention it in the params. So most of the API calls which we work with the client, they accept authorization, right? Apart from content type, so we can also specify here within the headers. And at the end, we can trigger this call with the help of HTTP dot, the kind of request method this particular API call has. So this particular API call had post. So we are going with the post, and then we are specifying URL, payload, and the params which we have declared above. And we are storing it in the response.
Okay, so let's write a quick script on this so that you know what Monica just said works. So I'm just gonna create a file which is a JavaScript file. I've named it first k6.js. I'm gonna zoom in a little more and let's do an import of HTTP because that's a protocol we're using from K6/HTTP. We need to get them in quotes. HTTP then, and now let's. So there's something called checks because you also want to check what response you're getting. That also comes from K6. And now let's write a default function, which was what is required to write. And I'm going to store my response in a variable. Let's call that variable res for now. And I'm going to HTTP get request so that it's quick. Just going to pick up a URL. So it's a test URL by K6 itself. And checking whether the response I'm getting is correct or not, right? So I use the same response res and the check keyword, and in that I'm checking is status 200. Okay, I'm checking that. Now that's what we're gonna get as output, and let's take the response r dot status and triple equal to because it's JavaScript. And I'm gonna give it a comma here. So now this is one script that should work, right? Because it has and we're inputting the right keywords, the right libraries. We've written in a default function. We have a get request, and we're also checking. Now let me just run this in a command line. Now to run this, we're just going to say K6 run and the script name, which was first. So I'm just going to hit enter. It's going to start K6 here itself. And it says that not a function, right? So there's a function error that says that you don't have an executor. You just have a default scenario and a stack trace, right? But it gives one user over here, and so you'll see 0 out of 1 virtual user getting used. Uh, so how did we get that? And the execution was for 10 minutes. How did we get that? Let's see, how did we get that?
Okay. So here, so as Ankur has written in the script that, okay, there are, with the help of checks, we can assert like, we can check what status our API calls are getting, and according to that, we can get the results. Okay. So the checks are like assertions, but they differ in what they act, how they actually work. So checks doesn't halt the execution or stop the execution, whereas assertion actually, in case the assertion fails, it stops the execution at that point of time. But checks doesn't do like that. Okay. So so in the code we have, so if we can see in our code snippet, so first we have imported the check from K6 library in the line number 2, and in the line number 20 we have put an check on the status. So it doesn't mean that, okay, we can just put a check on the status, and apart from that, so there will be a question that what all checks I can put. So you can put a check on, let's say, the time, the response time also. So we can put a check on n number of things as per our requirement or as per our validation, what we want to put on the performance in order to validate the performance of the API. Okay. So check is also one of the way. Next we have options. So options allow us to configure how K6 will behave during execution. For example, when we have ran the script, as Ankur has shown, so it has executed for one virtual user. Now, so for one virtual user, that is like by default. But in case if not in case, but I want to run my performance test for n number of virtual user, or let's say I want to just play with some different parameters, like I want to let it get executed for, let's say, so many seconds or milliseconds. So that also we can do with the help of options. So in the below snippet, we can see that options has VUS, which is like virtual users, which specifies that the number of virtual users to run concurrently used with duration. So in the duration, we just have to mention the number of seconds. And then there are other different common options available as mentioned below. So first we have executor. We are going to cover in the next slide. So next we have start time. So it's the time offset. It's the time offset after which the execution will begin. Then we have graceful stop. So instead of just abruptly closing the execution, so there is graceful stop added, so that the all the task which is like ongoing, they can stop as per the time which we mention here with the graceful stop. So next we have exec. Exec is the name of exported JS function to execute. Env is the environment variable specific to the scenario, and tags, which is also specific to the scenario. So this exec, env, and the tags, these three of them are optional, but we actually need to give the executor, the type of executor which we are going to use, the start time, and the graceful stop.
Okay, let's have a look at the options we can use. Let's just use the same script and create like a quick check on options. Let's just make sure that this was also running. Okay, so I made some silly error with the semicolon and stuff. That's why it failed. So this time we get a success over here of the previous script we created. And this time let's also add options. So I'm just gonna use the export keyword again and say let option, use an S because there are multiple options, and we'll say view as, let's do 5 users because one is default, and duration to be 30 seconds so that it's quick. Right? Just going to put a semicolon here so that it works this time also. I'm just going to clear this up and run it again. And you'll see it's looping between 5 users. So it's using all 5 virtual users, and the time over here is 30 seconds. So that's how we're playing around with it. Let it complete for 30 seconds. And we get all the checks worked, and then there's the amount of data we've received, the data we've sent, and the amount of request block, connection, the duration the request took, and the max virtual users over here, and the max virtual users that were assigned to it, right? And this is what is visible, that these are the 5 virtual users for 30 seconds that went on.
Yeah, so the result, the test result which we have just seen now is called as end of test summary report. So which is by default is added in the K6. Okay, so the next we have scenarios. So scenarios allows us to make in-depth configurations to how virtual users and iterations are scheduled. So we can add, it's not about adding a single scenario, but actually we can add multiple scenarios and can be declared in the screen in the same script, and each one can execute on the different JS function. And also we can configure these scenarios to either go in sequence or in parallel. So in the previous slide, yeah, in the previous slide, we have seen that, okay, these are the common options, like which includes executor, start time, graceful stop, and environment, env, or tags. So in this code snippet, if we see that under the scenario, there is a scenario name in the line number 6. After that, in the line number 8, we are actually giving the type of scenarios, the type of the executor, which we want this scenario to run. After that, we are giving the start. After that, we have this common scenario configuration, which includes start time, graceful stop, env, and tags. And after that, we are giving executor specific configuration, like for how many virtual user it should run, and how many iterations it should take, for how many duration, for what max duration. Okay, and after that we can add multiple scenarios. So there are other scenarios if we want to test with respect to this, with respect to the API call, we can also add that.
Okay, so the next is about executors. We mentioned few of them in our way. So executors are essentially the horsepower of all the scenarios we're going to execute. There are virtual users, and there's timing, and there are other options that are available. But what actually do these options do, right? So all these are keywords, that there is shared iterations. So there is a shared amount of iterations that need to be done by virtual users, right? So there is per use virtual user iterations, that per virtual users there's a limited number of iterations they have to go to, and each of them go through it. A lot of times you need a constant amount of load, uh, and then you want to ramp the virtual users. Then there are two additional ones which we can use, that there are constant amount of rate that's going on, and then you want to maintain that rate, so it's called constant arrival rate. You need an arrival rate for that, and then you constantly put that load. And then next is the ramping arrival rate, where there is an arrival rate and you want to ramp. So this idea comes from all the strategies which we talked about earlier, that what strategy you want to build, and similarly you want those scenarios to be built with these executors, right? When we talk about validating performance tests, it's more about the threshold you want to test. It's not whether you're getting a 200 or a 400. What you're getting, the more important thing is that your failure rate should be less, and the request duration should also be less. So for example, example over here is that we're using a request failure rate which is less than 0.01, which is really high, but it's still an example, and the request duration should be less than 200 milliseconds. Since we're using the test APIs, we come that low to 200 milliseconds, but then a lot of times you can actually configure how much do you need on the 95th percentile. There's something also called a group, which you can create. So group is more of like a description. If you use JavaScript, there are a lot of JavaScript libraries or test configurations which can be done. So you always use a describe and a init. Instead, you can just use a group, which creates a test scenario or a use case where you can group things together. Now, before I show you and walk through an actual example, there are different executions that can happen. You can run them locally. The tests you create, you can run them on a cloud. And the third one is a mixture of two, of running them on your local machine and streaming them on a cloud. So these are few commands. We used run K6, K6 run. We're going to use K6 cloud also. And then we are going to use K6 run minus option cloud also. So the difference between the three would be that while running locally, you're not saving those reports, right? On the cloud, you'll get a bunch of reports altogether, a visualization, and also like a collaborative report of all the scripts you've run. One limitation of the cloud currently is that we're using a free version which supports up to 50 virtual users. And so to at least build a configuration and confidence about the tool, you can use the free version of it. And other ones that's done, you need more virtual users, you can use a paid one. So let me just
Ankur, just a
yeah.
Ankur, just a quick time check, Ankur. It's 12. You'll have another 5 to 10 minutes, Ankur. 10 minutes max.
Yeah. So that's pretty much all we had here in the presentation. I think we walked through all this. We've seen this in the 2 runs we made, this reporting, and it's pretty basic. You get this for a local run. You can integrate different reporting also. There's Grafana. You can put in. There's also a database you need for Grafana to get that data from. So that's all there in the documentation, but for the basic functionality, you can actually use all this information which is there in the documentation, and it's well documented how to get a reporting. Otherwise, you can use cloud to visualize stuff the way we're going to do right now. So let's walk through, get a quick walkthrough to K6. I'll come back to my IntelliJ. And let's have a, so we understood this script and we run. So there's already a pre-built script which we've created to help you understand what a scenario skeletal structure would look like. So this is a keyword which we are going to use, and it's an array, so you can put in a bunch of different scenarios. You can give a name to the scenario. I've given it my test, my web test, because I have a default function which is web test over here, and in that web test I'm hitting the same API which was there over here, which is the test K6IO. There's another endpoint which is contacts PHP which I'm using, and then to give a sleep of random so that it takes a while to get execution, because the other one was really quick, right? Now, there's an executor which you select in the scenario you're building. So we're doing a scenario which has an executor of constant virtual users. Now, we talked about there are some common things which you have to put in a scenario, right? Some defaults, which is the virtual users, the duration, the graceful stop, the tag, and the executor. Now, when I know there are 2 default APIs which default functions I've created, and I want to run one scenario on one, the other on the other. So I tend to write an executor name which I want to execute. So if I move this particular parameter, this becomes one scenario which I want to use, right? Now let's write down another one which is already here, and I'm going to walk you through it. The other one is the constant arrival rate, where we're talking about there's an arrival rate and you constantly want to do that. In that so when we're talking about the arrival rate, and you more tend to talk about requests per minute. So how to define that? You define a rate which is 90 for 1 minute, which again translates to one request, 1.5 requests per second. That's the RPS, 1.5 requests per second. And how long duration? I want to do it for 1 minute so that you see a graph in the cloud that it runs for 1 minute. It's a constant arrival rate, right? So you need a rate to arrive to. So we're gonna do it 10, and the maximum virtual users you want to attain is 220, which you want to use. Like at maximum, if you want a rate and you want to achieve it, you can take 20 virtual users. The tag is to represent the API which I'm using, which is the API test over here. Now, the use of an external environment variable is that you can use the keyword env, and then you can give a value to this external variable in the API itself over here. So we've given a value of 1 because it's test, and this is the second API I'm executing. It's called API test. So this API test, and then this is a different API altogether. There's a third one also, which if the time is allowing us to do that, let's walk through that also, and then I'll talk about. I'll try the execution. Now this is about the ramping arrival rate, which a lot of time we use when we spike something. So this stage can be used independently also without like a scenario, so that you can create a ramping behavior. You need a start time when you're ramping. Like when do you want to start ramping? You immediately don't want to ramp because you also want to the application to set to a rate. So we're starting after 30 seconds. Our starting rate is 50. The time unit we're using is 1 second. So each iteration is of 50. Right, the stage we want to go to is 200. From 52 or 200 we want to go. That's the request rate, and duration is for 1 minute. So from 50 to 200 it goes for 1 minute, then it maintains that limit for 2 minutes, that is 200, and then after 30 seconds it comes down gradually. Pre-allocation is 20, so we're starting with 20. It would gradually go with 50, and the maximum. So these are all the virtual users we're talking about. This was the rate we're talking about, and the virtual users and rate is different. Like the rate of requests and the actual users you're using, right? What the rate is, what number of requests are gonna go. The tag again is used. I'm using the variable again over here, and the executor is test API. We want to discard any responses we get so that we don't get unnecessary logs, because we're trying to understand the performance over here. When you need logs, you make this true, otherwise you just use it. We're also defining 3 different thresholds because there are 3 different scenarios. So 2 of them are on the basis of test, which is at the 95th percentile, I get a 250 milliseconds response. At a 99 percentile, I get 350. For the website, I get a 99 percentile, 500 is acceptable. And for the scenario, which is the ramping scenario, I'm saying for 99 percentile, I need a 300. So this is all different thresholds you can put in. Now, let's just do a cloud execution and see what the visualization is about. What I'm going to do is run one, which is very interesting to me personally, is that how do you achieve a 1.5 request rate? So I'm going to go to my command line and let's run this on cloud. So I'm going to say cloud. Uh, and the name of the script is script itself. So I'm going to hit enter. I have a pre-logged in cloud over here. I'm going to go there. Uh, and let's see what happened. Okay, I'm going to refresh. Hoping this takes some time. Okay, so there is a performance test that started over here in my project, and the name was script itself, and it started right now. So this is starting. So you'll see there's the request made, the HTTP failure, the active virtual users, and the rate over here. And over here, if you see, there are three lines which you'll see: the blue one, the light blue one, and the purple one. The gray, the blue, and the purple one. So these are response time, request rate, and the active virtual users. Let's just have a look at the number which is for the request rate. So over here, the first one says 2. The second dip says 1, 2, 1, 2, 1. So you get a 0.5 request rate that you were trying to achieve. And you'll see that it's really well visualized. The other thing I want to show is that there are different thresholds that are visible over here, which you defined, and the HTTP request is over here, right? So this is the response time graph, which is available for you. This is the script that's getting executed, which you can edit if you require. And there's the comparison if you want to add. So you can add like a comparison. I can add a new matrix of whatever I want. If I want something of response times, I can just say response times of this and I get a separate matrix. If I want the connections of the particular request, I get a different matrix of the different connections that are happening. This got finished, but it gives a good insight of it takes 1.5 minutes, the 20 virtual users that were used, and these are the graphs. And there's a time zone of US, which is it's using right now. Let's come back to our presentation. So that was the walkthrough. These are the different references we took. So this is the K6 documentation we used. We created a GitHub repo which we used for demoing, and there's also something on pods we read to understand how the infrastructure goes for this. I'll open the floor for Q&A if anybody has any questions.
I guess there was one Q&A pending, Monica. You told you'll answer at the end of the session.
Yeah, so Ankur, there is one question that when should I consider using K6 as we have Gatling, JMeter, and Locust?
It's just a new tool, K6. So you should. I just am enthusiastic about new tools, but also K6 is something which you want to use when your application is heavily relying on JavaScript. This is one of the JavaScript run tools. And the other thing is that it doesn't need that much configuration. You don't need Node to install it. You just need one K6 live application that runs in the background, and then you can just use it, right? With Gatling, I understand it is a similar tool, but then you have to have a skill of writing your code in Scala. JavaScript is relatively more common, I think, than Scala. But then Scala comes with its own advantages. JavaScript comes with its own advantages, and JMeter itself is a giant that you write scripts in Java with. But K6, while exploring, you might need a different tool that's much lighter and easy to set up.
Yeah, apart from that, I guess K6, what K6 doesn't support right now is distributed clustered machine. So they are working on it, but it's not supported yet.
And there is one more question from Ramesh. What is the license it's under?
Could you repeat that?
The question is, even it's not much clear, it is what is the license it's under? It's like, is it any licensing or Ramesh, it's not much clear, Ramesh, the question is.
Okay, so I what I got from the question, that is K6 a license tool? If you so if your client is ready to spend, and if you need more than 50 virtual users in the first place, you need a license for it, because there's a paid version to it, right? Now the it's not a license tool. It's an open source tool. K6 is an open source tool. The only thing that is required is that you start paying when you need more virtual users. Currently, what I'm using is a free account that lets me go till 50 virtual users. I hope
Yeah,
this answers.
but I think this K6 CLI is complete open source. But when it comes to K6 Cloud, so what Ankur said is applicable.
And then if you don't want to use the cloud, if you want to integrate with your let's say Grafana as a tool for reporting, you can put in as many users as you want.
Awesome.
So use InfluxDB to store the data, and then to visualize, you can use Grafana.
We have one more question. We'll close with this question. The question is, K6 tool is same like load runner or JMeter or different from that?
K6 is very much different from JMeter because in the K6 we are writing the code, and there are other features like which K6 also support, that is like work towards in case if we have APIs which are already there in place, we can, instead of writing the code, they have the generator to ease our process of writing the test.
Awesome.
And also to just test your, like to write a basic script, you can quickly go to the cloud. You can write your own API over there and test that API, and you'll understand to how to set up also your test. So a lot of time also takes up when you start setting up your performance test to understand whether this API would work or not, right? So to do that also quickly, you can use the cloud.
Yeah, so the actual ramp up time when compared to, let's say, Gatling also. So the ramp up time in case of K6 is comparatively lesser because you don't have to worry about Maven setup. You don't have to worry about, adding the dependencies, then learning the Scala. And there are other things also which you have to learn about injections or simulations. So in this, everything is comparatively easier.
Cool. If there is no any other questions, then we'll end this talk. That was a good session, Monica and Anku. Thank you so much for that.